Hi everyone, my name is Brenda and I'm going to be talking to you guys about how to store your passwords safely as a developer. So as consumers, we deal with passwords almost on a daily basis. You log into your phone, your apps, your Facebook, your Instagram, but we haven't really talked about how to verify those passwords and make sure you're storing those passwords safely as a developer. So let's just start with this. So if you see this login page, let's say you've created this beautiful login form, how would you go about storing your password in the database so that you can later verify that with what the user enters? So your first approach may be just to take that data and to just enter it in the database. You could just take the password from the user and store that as it is into the database. And I see a lot of you, that is not a good idea, and you guys are onto that. This does have a couple of advantages though. You could send the user their password back if they say they've forgotten their password, and it's very, very, very easy to just verify and quickly check the password in the database. But yeah, like you guys have caught on to, that is not a good idea. Do not do this. That will be very, very, very not secure, so that if anyone has access to your database, just anyone who works there or even just hackers, they can get access to everyone's login information. That's not what you want. So what's the next approach? It's something that we've kind of talked about. If we can hide our data behind an algorithm, so we could use encryption. And encryption we've kind of talked about before, but as a refresher, you take that plaintext password, you put it through an algorithm, and it kind of scrambles it into these unrecognizable string, and you have that cipher text, and you store that in the database instead of the plaintext password, so that if anyone looks at that password, they're not going to be able to just take that from the database, enter it into the password when they're logging in, and just have access to that user's information. But still, this is not a good idea. And this is because if you're encrypting, that means you can also decrypt. And so if that user or if an attacker has access to your logarithm or whatever function you use to encrypt your data, then they have access to decrypt it back. And that's not what you want to do. Also, don't do this, yes. And we talk about this, and there are still really big companies doing this kind of thing. In 2013, Adobe lost millions and millions of passwords in a breach, and they confirmed they were only using encryption. And as you can see, the next step is to hash. But unfortunately, when you encrypt your data, all you're doing is, so what happens is if two users have the same password, their stored result in the database would be the same thing. So if you have two users and their passwords in the database, they're scrambled passwords in the database are the same, then you know they have the same plaintext password. And then this was a really, really bad idea because the hints to the passwords were stored along with the scrambled passwords. So they were like, oh, these two people have the same scrambled password. And one of the hints says furry, one of the other hints says man's best friend. It's oh, dog. Okay, so easy. So you do not want to be doing that. So the next better approach is something that we haven't really talked about a lot, and it is hashing. Yay. So maybe you've heard about it before, but before this, I didn't really have a good grasp. What are hashing algorithms? What are they? So hashing algorithms are functions that take in any data of any size, and they turn it into a fixed length result. So if you hash hello, it turns into this. And they are also, another thing is, if you change your data, your input data by even 1 bit or any letter, your stored result changes, the whole stored result changes as well. So as you can see here, even though we changed only 1 letter in hello, the whole result changes, so that you don't see any correlation between two passwords and say oh, these two, if I just change that 1 letter, I can crack that. So you don't want that. They're also they can't be reversed. Of course, there's ways around this, but computationally, you can't reverse it. And that's a good thing because once you hash your password, you can't go back. The only way you can break in is by brute force. Maybe you take all these common passwords, you run it through the algorithm, and you compare your result with the results in the database. But you can't decrypt it, which was one of the problems with encryption. So there's still kind of something that we're missing here. Because if you take a hashing algorithm and you take your password and you run two users with the same password and you run it through the hashing algorithm, they still have the same password. That's not good. So what can we do to kind of help this out? We can add a salt. So salts, what are salts? Salts are random bits of data added to the end or beginning of a plaintext password that you then hash. So let's say, for an example, you have your password 123. Salts are anything just like randomly generated data or like a string that you just add to your password. And instead of just passing your plaintext password, you hash the whole thing. You run that whole thing through the hashing algorithm. So this is really good because for each user, you can have a different salt. So even if two users have the same password, you would end up with two different resulting passwords in the database. And this, again, kind of the same thing. It reduces collision. Like even if two users have the same password, they won't have the same hashed password in the database. So what can we actually use to implement this hashing algorithm and everything that we've been talking about so far? From all the research that I've done, it seems like Bcrypt is the way to go. And it's funny because in computing, we always talk about speed and how fast, and you want things to be of optimal speed. But in this case, Bcrypt works, and it's the best because it's slow. And that's really weird to think about. Why would you want your hashing algorithm to be slow? And that reason is so that if attackers wanted to just take every possible word and put it through the hashing algorithm and get that result and just compare it with your with what you have, it's going to take them forever just to run it through that algorithm. So if you see here, these are other popular algorithms or hashing algorithms that you use, and you can see that even though it's still fast, for all the other ones, it's hundreds of millions of words per second that you can process. But for Bcrypt, it's 25,000. And that's a huge, huge, huge difference if you're working with security. So even though Bcrypt is slow, just to clear it up, it is fast enough that the user won't have a noticeable difference in their experience, but it's slow enough that if you were just trying to run massive amounts of data through it, it would take you forever. So let's see how you would actually implement this if you were coding it out. And you would just require it in. It's actually really helpful because we have it available in NodeJs. So you can require it in, and you have this thing called salt rounds, and I'll be explaining in detail what that means. And you also have your plaintext password. So from there, all you would have to do is use this function, bcrypt.hash, enter your plaintext password, enter the amount of salt rounds, and somewhere in there, you would tell it, store this in my database somewhere. And I can further talk about salt rounds. So this is another layer of protection that Bcrypt makes available to the user. Rounds means it's not talking about the salt, actually. It's talking about how many times your data is going to be run through that hashing algorithm. So let's say you take from before that password and you add the salt. You take that, you put that through the hashing algorithm, you take the result, and you put that through the hashing algorithm again. So that's another layer of security because if someone is able to get through into your systems, they don't know how many times you have put it through the hashing algorithm. So you're probably thinking, if it's so impossible to break into, how am I going to check my passwords? So it actually has a built-in method where you can just say bcrypt.compare, and you would put in the plaintext password that you want to compare with what you have in the database, and the hash is whatever you stored in the database, that resulting string. And then inside of there, you would just get the response, res, which would be equal to true. And you can do whatever you want with it in there. Maybe you want to set it equal to something else. And if you guys want to learn further, there are like docs on Node. There's also like resources to explain why like Bcrypt is better and why being slow is better. So yeah, thank you.